Now that we have discussed about quadrants, the four types of quadrants in the coordinate system or the Cartesian system, let's see how we can just use its significance in real life. But before that, it's very important to identify that how we locate the point in the quadrants is what is the biggest question in coordinate geometry. So before we understand the real life situation, let's get into the coordinate system in which the points are located. So quadrant and the rules of locating of a point is what is the session for today. Locating a point using quadrants is what we deal with once the topic of quadrants is learnt. So now that we know the rules of each of the quadrants, quadrant 1, quadrant 2, quadrant 3 and quadrant 4, next comes on how we can locate through their own respective definitions. So let's revisit the quadrants which we have learnt in the previous session to understand the locating of a point. So let's see how we can locate a point. Now when it comes to x and y axis, and this, now let's try to locate some points on x and y axis positively, negatively on either sides of the origin. So here I have the positive x values as discussed, and let's locate them with 0, 1, 2, 3, 4, 5, 6 and so on and so forth. Negative 1, negative 2, negative 3 and etc. Here lies 1, 2, 3, 4, 5, minus 1, minus 2, minus 4, minus 5, etc. So I have each of the x values on x and y axis as we have already discussed in the previous session. Now let's see how we can locate a point in the respective quadrants. As we have discussed, the first quadrant denoted by Q1 lies in this region, and the second quadrant denoted by Q2 lies in this region, and the third quadrant denoted by Q3 lies in this region, and the fourth quadrant denoted by Q4 lies in this region. So each of the denotions of Q1, Q2, Q3 and Q4, let's see how we can locate a point in its respective quadrant. So for example, I have the point generally denoted by x, y. So before we enter into locating a point, let's recap on how the notation is done for a point. What is the rule for locating or denoting a point with the symbols? So when I take the point P, generally I denote with the open brackets with x, y, where x refers to the first value or the x coordinate, that is a value on the x-axis, and y refers to the y coordinate or the value on y-axis. So here I have this value which lies on x-axis, and here I have the value which lies on y-axis. Is how the rule is applied for the point. The point generally denoted by x, y. So for example, I have the point as minus 3, 2. For example, I take P as minus 3, 2, then this clearly indicates that this is the x coordinate and this is the y coordinate. So for example problem, minus 3 is the x coordinate and 2 is the y coordinate. And minus 3 So x coordinate here is -3 and the y coordinate here is 2. Therefore, my x coordinate is -3 and my y coordinate is 2. As we know that the x coordinate is negative in this example problem, clearly I understand that it being negative, x value lies on the left of the origin. So I have the x coordinate. Usually each of this represents 1 unit. Each of the distance represents 1 unit, and therefore I break every x-axis into 1 unit subdivided path, and equally the y unit also is divided into 1 unit subdivided path, which indicates that -3 refers to the -3 units on the left side. The negative sign indicates on the left. So with the x values being on the negative side, I have 1, 2, 3. I move 3 units to the left, and therefore my point P is said to be initially with x value out here, and then my y coordinate being equal to 2 indicates that this is the positive y value, which clearly can be identified in this quadrant as the positive y value, which is 2 units up. So I move 2 units up, but I don't move from origin, because first it moves through x-axis and then it moves through y-axis. So a point P moves first 3 units left and then moves 2 units up. This is where finally the point P moves. So when I locate the point -3, 2, I understand that it moves 3 units left and 2 units up. And finally, I see that this point P is now in the second quadrant. So the point P, which is -3, 2, lies in the second quadrant, is how we locate the point in each of the quadrants using the definition of quadrant concept. Quadrants and locating a point are very much connected through this example problem. Now let's take another example problem to understand the concept more stronger. Let's take an example in which my question says, locate the position of the point A equals (2, -5/2) in the Cartesian system. So my question out here is, locate the position of the point 2, -5/2 in the Cartesian system. So let's see how we can locate the point using the rules of the Cartesian system. The first thing what I do before I locate the point is, of course, construct the Cartesian system, the base for locating the point, the base for identifying its quadrants. So let's construct the Cartesian system. Intersection of horizontal axis and vertical axis is what is called Cartesian system. Intersects at origin. This is x-axis and this is y-axis. And then let me take some points out here. I have the negative y values. In this manner. Now comes the question on how to locate the point. So let's get back to the point A, which is given to be 2 and -5/2. As clearly seen, that this region is called the quadrant number 1, and this region is called the quadrant number 2, and this region is called quadrant 3, and this region is called quadrant 4 in the anti-clockwise direction, Q1, Q2, Q3 and Q4. Now with this, we also know that the first value of the given point refers to x coordinate and the second value refers to the y coordinate. So here my x coordinate is 2 and my y coordinate is minus 5 by 2, which is in decimal form as negative 2.5. Converting to the decimal form, minus 2.5 is my y coordinate, 2 is my x coordinate. Now comes in locating this point in the Cartesian system. So as I see here, I see that this point is x coordinate, which is positive, and this is 2 units, which makes me understand that the origin moves 2 units to the right initially, and then it moves towards y coordinate with a distance of negative 2.5 units. So here I have this point which moves 1, 2, 2.5. So I exactly have this point moving negative 2.5. Oh, this would be in the down. So I have this to be moving 1, 2, 2.5. So I have this exactly moving at negative 2.5. Therefore, I have my point which is now located at this. My point A is out here, which is 2 comma minus 5 by 2 or minus 2.5. So the point A is identified in the Cartesian system to be in the 4th quadrant. Using the rules of the Cartesian system, we can locate any point, this point being in the 4th quadrant. Any point in XY coordinate system can be located using the rules of the Cartesian system.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.